Okay, the directions for question number 9 from tonight's Advanced Algebra 2 homework says to find the roots of each polynomial equation. Given that this is a fourth degree with 1, 2, 3, 4, 5 terms, we're going to have to use a calculator. Now, you don't have to do this, but according to the rational zero theorem, it says that if this particular function has any rational zeros, because it's a fourth degree, it doesn't have to. It could have 2 irrational, 2 imaginary, 4 imaginary, 4 irrational, or it could have 4 rational as well, but it doesn't have to. But if it does, the rational root or rational zero theorem says that it has to be one of the following. We take the factors. P is all the factors of the constant term. So we have plus or minus 1, plus or minus 3, plus or minus 7, and plus or minus 21 over all of the factors of A, which in this case are 1 and 2. Now again, it is plus or minus, but we don't need a plus or minus in both the numerator and denominator. It's redundant because it will end up becoming in the end just positive or negative. So here, our possible rational zeros are 1, negative 1, 3, negative 3, 7, negative 7, 21, negative 21. Those are all over 1. And then we have 1/2, negative 1/2. 3 halves, negative 3 halves. 7 halves, negative 7 halves. 21 halves, and a negative 21 halves. So if this particular polynomial function has any rational zeros, it has to be one or, I guess, several of these. So what we would do is we would then take this and we would plug it into our graphing calculators, which I haven't done already. We would plug it in, and then we would find the zeros. Using synthetic division and get this fourth degree polynomial to the quadratic formula. So that's what we'll do. So under y equals, we'll clear out what we have. And under y equals, we'll plug in the polynomial function for question number 9, which is 2x to the 4th minus 5x cubed minus 17x squared and I always do that. This should be cubed, sorry about that. And we have minus 17x squared plus 41x minus 21. Okay, go ahead and clear this one out. Not that it's really necessary, it was turned off anyway. And when we graph it, here's what we see. So it looks like all of them are real. This one appears to be at negative 3, but we'll double check that. Here we appear to have a double root. And then here, 3 point something. But let's go ahead and find at least one of the rational ones. So we have second, calc, 0, left bound, right bound, guess. I'm going to scroll over and I'm going to try to find this 0 right here to the far left. There went our marker. So left bound would be up there. Arrow over right bound and guess. And it is in fact negative 3. Okay, so if we head back here, okay, what we see is that was in our list. So negative 3 is 1. What we can do with that now using either synthetic division or long division, I would recommend synthetic division. If we would take this, we would divide out this 0. Now we should have a remainder of 0. Okay, bring down the first coefficient, multiply, add those together, multiply, add those together, multiply, add those together, multiply. Should be negative, sorry, so this will be positive. Alright. So this is 0. So what we've done is taken this from a 4th degree polynomial down to a 3rd degree polynomial. Okay. Now we need to continue to work that down to a 2nd degree so we can plug into the quadratic formula, because even though we now have 4 terms, trying to factor this will not work. So we come back here, we need to find at least one more. So we'll go to second calc. We'll go to 0 again. Even though it does look like we have a double root. It might be a little bit tougher to find. I'll find the one to the far right if I can. Okay, here we go. Left bound, right bound, and guess. We have 3.5. And this, remember, -1 times 10 to the -11th is 0. So 3.5, let's make sure we have that. That's 7/2. So let's come back here, and 7/2, again, was one of our options. So here we have it. Okay, 7/2, or 3.5. So now we're going to take it, we're going to divide that out. We'll just use the coefficients. Okay, so 7 halves, we bring down the 2. Okay, this will be 7. Add those, that's a -4. So that's -28. That would be a -14. We add that together, we get +2. Here when we multiply, we get 7. Okay, so now that's 0. We've taken a 4th degree down to a 3rd degree. Now it's a quadratic. Now we can take what's remaining and plug it into the quadratic formula if we can't factor. First, I would try to pull out my GCF. And then from here, we can factor. It's a perfect square trinomial. So we can now set our factors equal to 0. And we do see that we have a double root, or x equals 1 with a multiplicity of 2. So we found our 4 roots. With the help of our calculator, -3, 7 halves, 1, and 1. And that's one way of solving question number 9.